Okay, today we're going to talk about intermolecular forces. The first, most important thing to realize that intermolecular forces are between molecules, not between atoms. So for example, if you have a water molecule, intermolecular forces would be between the actual water molecules themselves, not between the oxygen and the hydrogens in the water. So that's the first, most key important thing that you have to remember. Now, there are various different types of intermolecular forces that vary in strength. The first and the most weakest are Lewis dispersion forces. Lewis dispersion forces, London dispersion forces, arise by displacements in the arrangement of the electrons. What this means basically is that at certain instance in time, the electrons will be unevenly distributed within the electron cloud. So at one point there may be more electrons on one side of the atom as opposed to the other, as you can see here. And as a result of this, partial charges will form. So the side that has more electrons will have a partial negative charge, and the side that has less electrons will have a partial positive charge. Now, realize that these aren't sustainable as the electrons are constantly shifting around, so they form what we call instantaneous dipoles, which means that the forces are instantaneous and they don't last for a very long time. It's important to realize, though, that that London dispersion forces are found in all types of molecules, and that they're also the weakest. The next one, the next strongest one, are dipole-dipole forces, and this is between polar molecules. What we mean by polar is that there are polar bonds within the structure, within the molecule, that, like the London dispersion, the electrons are unevenly distributed. So one end of the bond may have more electrons than the other. And as a result, what will happen is we have the partial charges that arise. So once again, partial negative will arise where there are more electrons, and partial positive will arise where there are less. And what will happen is, because this is happening within each molecule, forces of attraction and repulsion will occur between these molecules. So so ends of the molecule where there is a partial positive charge, that end will be attracted to the side where there is a partial negative charge. Likewise, partial positive charges and partial negative charges will repel each other. But it's important to realize that this is between polar molecules, which is why the partial charges arise in the first place, and that this is stronger than London dispersion forces. The next type of force is ion-dipole. And the ion-dipole forces are generally seen, a common example is with sodium chloride when you dissolve it in water. What will end up happening is the sodium and the chloride, because it is ionic, will end up breaking down. So you'll have sodium cations and chlorine anions. Within the water molecule itself, as we know, is a polar molecule, which means that the oxygen has a partial negative charge because it is more electronegative and thus draws the electrons toward it, and the hydrogen has a partial positive charge because it has a lower electronegativity and thus has less of the electrons. So what ends up happening is the positive cations, the positive sodium cations, are attracted to the partial negative oxygen atom. Likewise, the negative chlorine anions are attracted to the partial positive hydrogens. And as you can see, forces of attraction arise. Now, these are stronger than dipole-dipole, but you have to keep in mind that this only occurs in certain scenarios where ions and dipoles are present. The final type of intermolecular force we're going to discuss are hydrogen bonds. Hydrogen bonds are a type of dipole-dipole bond. Basically, it occurs when you have extremely electronegative atoms bonded to other atoms. So for example, the most common ones that we'll see are fluorine, oxygen, nitrogen. When these atoms are bonded to a hydrogen, not surprisingly, a partial negative charge and a partial positive charge will arise due to the fact that the fluorine, oxygen, nitrogen have high electronegativities. So what will end up happening is that if you have multiple molecules with these forces, with these partial charges, forces of attraction will appear. The most common form of hydrogen bonding and the most important to life on Earth is seen with water. Now, like we said, water is a polar molecule, because as you can see, you have oxygen bonded to hydrogen, and a partial negative, partial positive charge forms. So what will happen is the partial positive hydrogen of one oxygen molecule will be attracted to the partial negative oxygen of another molecule. Likewise, the partial negative oxygen of one molecule will be attracted to the partial positive hydrogen of another. And thus, these hydrogen bonds are what gives water its key characteristics. Other examples where you can see hydrogen bonding is in ammonia, which is NH3, because we have the nitrogen bond to the hydrogen. Hydrogen bonds are generally the strongest of the intermolecular forces. If you have any further questions, you should consult other additional chemistry resources, such as your chemistry teacher or a textbook. Thank you.